theoretical and experimental probability. What? Nope. I'll give you one in a little while. Okay, probability is a measure of how likely an event is to occur. Okay, all of you have probably played some kind of game where you've done a little bit of probability work in it, whether it's flipping a coin or rolling a die. Okay, lots of times you probably played games where you've had to roll a die at least. And in some sporting events, they have to flip a coin to decide what's going to happen. Right? And some people have the thought process when it's flipping a coin, they have the saying that tails never fails. Okay? And so some people will always use tails, even though that there's supposed to be a 50-50 chance of getting heads or tails, they'll select tails. Each possible result of an experiment or situation is called an outcome. So when we're talking about flipping a coin, there are two outcomes, a head or a tail. Rolling a die, you get a 1, 2, 3, 4, 5, or 6. Spinning a spinner, you could have 4 different outcomes. Sample space is the set of all outcomes, and an event is an outcome or set of outcomes. So here we could roll a number cube, get the numbers 1 through 6. Spin a spinner, get red, blue, green, or yellow. Probabilities are usually written as fractions, sometimes decimals, but most of the time you're probably going to use fractions for them. If they're equally likely, they have the same chance of occurring. So for instance, each of these with the rolling the number cube and spinning a spinner are all equally likely because they have the same chance of being a result. Favorable outcomes are the ones that you're trying to get. And for equally likely outcomes, the theoretical probability of an event is the ratio of number of favorable outcomes to the total outcomes. So our theoretical probability, when we're trying to find the probability of something, we're basically going to take the number of favorable outcomes, okay, the successes, you can say, and we'll divide that by all the possible outcomes. So for instance, if I rolled the number cube and I was hoping to get a 6, okay, how many favorable outcomes are there? How many successes would there be? If I roll a number cube, how many successes are there possible if I'm looking for a 6? There's 1. Okay, there's only 1 6 on the number cube, so I only have 1 favorable outcome. But how many possible outcomes are there? 6. So if I take the number of favorable ones, which is 1, divided by the total number, which is 6, so I'd have a 1/6 chance of getting a 6. Right. So here we have the word probable. And each letter is written on a separate note card. Place them face down, mix them up. What's the probability that a randomly selected card has a consonant? Okay. It's the probability that we get a consonant. So first of all, whenever I do these, I prefer to do the total outcomes first and then work with favorable. So the total outcomes in this case are the number of letters. So my denominator is total outcomes. And my numerator is the favorable ones, or successes if you want. So how many possible outcomes are there? How many letters are there in the word probable? Okay, there are 8 letters. So I have 8 possible cards I could pick up. And how many of them have a consonant? 5. So my probability of getting a consonant would be 5 out of 8. And hopefully most of these that we do be like, okay, yeah, I know that. Right? That's not overly difficult. Now this little chart here is used for rolling 2 die, or 2 number cubes. If we have 2 number cubes and one is red and one is blue, These are all the possible outcomes. There are 36 different possible outcomes if you roll a number cube. Now, you're going to want to make sure that your book is open to a page where you can see this, which one of those pages would be 803. Because we're actually going to be using this quite a bit. So you want to have easy access to it. So we roll 2 number cubes. What's the probability that the difference between the numbers is 4? So we need to talk about our total outcomes and favorable. So what are the total possible results I could get? How many possible results are there if I roll 2 number cubes? Okay, there are 36 of them. Okay, because I could get a 1 through 6 with my red die, and I could get a 1 through 6 with my blue die. So there are 36 possible outcomes when I roll 2 number cubes. And they're all right there in red and blue. How many of them are favorable? In other words, how many of them have a difference between the two? It's 4. How many of them? How many? 3? Which ones? Difference between them. Okay, all right, not the sum, the difference. Good try, though. Okay. What, Michael? 1 and 5, okay, so we've got 1 and 5 here, 1 and 5 up there, so there's 2. Are those the only ones that have a difference of 4? Okay, 6 and 2 and 2 and 6. So there are 4 out of the 36 are favorable. So the probability of getting the difference of 4 is 1/9. Okay, and whenever you have fractions, you should always simplify them. Don't change them to a decimal or don't change them to a percent unless it tells you to. Basically, just work with fractions. Now, this talks about the complement. And the complement, you really don't use it a whole lot because you just think your way through them. But the complement just means that if I'm talking about the number of girls in the class, the complement of that would be the number of boys in the class. Okay, so it's just basically thinking about the opposites. But always, the 2 probabilities, if it's this situation or that, the probabilities always have to add up to 100% or 1. So in this problem, it says there's 25 students in study hall. The table shows the number of students who are studying a foreign language. What's the probability that a randomly selected student is not studying a foreign language? How come there's no tie in there, huh? Nobody studies that language, right? Okay. So, how many people are actually studying a foreign language here? 21 out of 25, right? Okay. So how many people are not studying a foreign language? Okay. So the answer here would be 4 out of 25. So what we could do is take 1 minus the number that are studying a foreign language, and we would get the amount remaining. Okay. So that's where the complement comes in. I could do 1 minus the probability that somebody is studying a foreign language, and I would find the probability that they are not studying a foreign language. Okay, Jocelyn? There's only 21 people represented here, so there's 25 altogether. So 4 of them are not doing this. Okay? Okay. Finding probability with permutations or combinations. So we're going to be using this quite often when we're dealing with probabilities. We're almost always using that formula. Favorable outcomes in the numerator, total number of outcomes in the denominator. So here we've got a student receives a 5-digit locker combination. What's the probability of receiving a combination with all odd digits? So we need to talk about this. We've got favorable in the numerator and total in the denominator. Okay? So we're talking about 5-digit locker combinations. Okay? The favorable in this case is all odd digits. The total in here would be all possible digits or all digits. So how many digits are there? I should say all digits, or I should say all 5-digit locker combinations. So how many 5-digit locker combinations are there? Well, let's see. How many numbers do I have possible for the first number? For all possible ones. Okay? The first digit I have 10 choices, right? 0 through 9. The second one I have 0 through 9. Third, fourth, and fifth. So all the 5-digit combinations is 10 to the fifth power. Right? 10 times 10 times 10 times 10 times 10. Okay? But they want to know, okay, what's the probability of just getting an odd digit? Well, how many odd digits are there? Yeah, there's 5 of them, right? 1, 3, 5, 7, and 9. So the first one could be odd, the second one could be odd, or third one's got to be odd, fourth one's got to be odd, and the fifth one. So we're going to multiply together 5 times. So the numerator here represents the number of favorable outcomes, okay? All my digits on my locker combination are odd. The denominator represents all possible 5-digit locker combinations. So what's 5 to the fifth power? Okay, so in the numerator we have 3,125, and in the denominator we have 100,000. So will this fraction reduce? I hope so. You guys know how to reduce this fraction in your calculator? Nope. 3,125 divided by 100,000. And math, fraction, and enter. So it's 1 over 32. So out of every 32 people, so basically, okay, this is what this means. There's 32 people in this classroom normally, okay? One of you would have all digits for your combination. Okay, we would expect that to happen. Okay, would it always happen that way? No. Okay, could be more than one. Could be less than that. Okay. So 1 out of every 32 people would have an odd, or all their digits would be odd on their locker combination. So we find that by the total number of outcomes divided by the favorable ones. Okay, let's look at this one together. A DJ randomly selects 2 of 8 ads to play before her show. 2 of the ads are by a local retailer. What's the probability that she will play both of the retailer's ads before her show? So what's happening here? In general, the DJ is doing what? Choosing 2 of 8 ads, right? Okay, let's just stay there with the total amount. Okay? The DJ has 8 ads, and he's going to choose 2 of them. Is there order to the way that the DJ chooses the 2 ads? If I have to choose ad A before ad B, or it doesn't say, does it? Okay. So this is our denominator here. Then is a combination of 8 choose 2. We have 8 ads. We're choosing 2 of them. No order. It's a combination. Now the favorable is this. How many ads is the DJ going to choose? 2. How many does this local retailer have? How many does the local retailer have? 2, right? Says 2 of the ads are by the local retailer. What's the probability that she will play both of the retailer's ads? So does it say what order she's going to play those 2 ads? No, right? So there's no order to that. So this is a combination. Okay? And it's a combination of she's going to pick 2 ads to play. And how many does the retailer have? 2. Because it's specifically then the favorable here is specifically focusing on the retailer and the 2 that they pick. They pick 2, the retailer has 2. It's a combination then of 2 choose 2. Well, whenever you have a combination of, whenever it's a combination and both these numbers are the same, it's always 1. It's a permutation and both those numbers are the same, you just multiply, you have that many factorial. So what's a combination of 8 choose 2 though? Because remember, a combination is just a permutation divided by this number here, factorial. 8 times 7 divided by 2 times 1. 28. Right? And here's why. Okay? Watch this. All right? If it's combination, okay, 8 factorial is that, right? All right, so let me simplify this for a second. All right, this is a combination. Oops. 8 factorial over 2 factorial, 6 factorial. So I could, instead of writing out the 6 factorials for the numerator and the denominator, write it once and cancel them. Okay. Save my writing. Don't want my hand to get tired. And when you're doing combinations, okay, you can simplify your multiplying this way. Anybody looked on the calculator to find buttons that involve combinations or permutations yet? Yes. Or factorials? Okay. So we're looking still at favorable in the numerator. Okay. total in the denominator. So with these problems, you got to figure out which one is which. All right, you focus on the total possible ways it could happen, and then the specific. Okay, geometric probabilities. How many of you know how to do the area for circles, triangles, and rectangles? Hopefully you all know how to find the area for a circle, triangle, and a rectangle. If you don't, you need to brush up on your finding the area, because we're going to do it. Here we have a rectangle with a triangle inside that and a square inside and another rectangle inside that. Or actually, excuse me, it's a rectangle, a 4 by 3 rectangle in a triangle inside a square. And we want to know what's the area of the shaded part. So total, favorable. Well, when I talk about total here, what am I talking about? The total what? Okay, the area of the whole thing. Okay, when we're talking about a figure like this, the total part is the total area, where the favorable part is the shaded portion of that. So what's the total area here? Okay, it's 9 times 9, right? 9 by 9. The shaded portion is a triangle, but it's missing part of it. So how do I find, so what's the area of the triangle, first of all? How do you find the area of the triangle in this case? Okay, so it's half. So we've got, it's 9 across, the base is 9, the height is 9. So 1/2, 9 times 9, right? Okay. But they cut out this part, this rectangle, which is what? 4 times 3. Now this is where your calculator is going to come really handy. Okay, the denominator is 81. Half of that is 40.5, and we subtract 12, we get 28.5 here. All right, the area of the whole square is in the denominator. The area of the shaded portions in the numerator. You did these back in middle school or pre-algebra. If you did pre-algebra, you did stuff with shaded areas and finding areas of them. So now, I want this answer as a fraction. So you just pull out your calculator, 28.5 divided by 81, because you can't leave a decimal in a fraction. All right, then you go back and change it to a fraction. We get 19/54. Total area is in the denominator. The specific area we're looking for is in the numerator then. Experimental probability, no different, except for they've actually conducted an experiment and using that information. Okay? So instead of, so if we take that spinner they showed at the beginning with those 4 colors in it, and numbered them 1 through 4, and somebody spun the spinner a bunch of times, okay, here's the results. Now, if everything was perfect, those numbers would all be the same. Okay, but perfect worlds don't usually happen, especially if you go to a fair or something like that when they want you to do one of those things and it's supposed to be, yeah, I know it's always weighted one way or another, so you can't win very often unless you're really lucky. But still, the formula we're using is basically the same thing. It says number of times the event occurs divided by the number of trials. Okay. Well, that all that is the favorable outcomes divided by the total number of outcomes. So here we have somebody that they spun the spinner a certain number of times, and these are their results. Well, the first thing is we need to know what is the total. How many times did they spin the spinner? They spun it 10 times? They spun it 50 times, right? Right. 17, 36, and 14 is 50. All right, there was a total of 50 spins of the spinner. So for letter A, they want to know, okay, how many of those was a 4? How many of those 50 spins did I get a 4 on? 14 out of 50, or 7 out of 25? How many times do they get a number greater than 2? Okay. Do I count 2? If it says greater than 2, do I include the 2? No. Okay, so we have 19 and 14 is 33 out of 50. So 33 out of 50 times they got a number greater than 2. Should be 25. All right, must be weighted a little bit somewhere. Okay. So all of this probability stuff deals with favorable outcomes in the numerator, total number of outcomes in the denominator. If you can figure out those two things, okay. For most of the part, it's not too bad when you're dealing with the problems that involve permutations or combinations. They'll get a little bit tougher, and people have a little bit harder time with the geometric ones. But just take the things that you've learned as far as those are concerned and use them.